Assalamualaikum and selamat sejahtera. My name is Muhammad Aikal and I'm from group 3, and we're going to be presenting about experiment 7, estimation of heat capacity and entropy generation. So the group members are myself, Muhammad Afan bin Zubidi, Muhammad Al-Hafiz bin Muhammad Kasim, Muhammad Arsi, and myself. So next slide. So right now I'm going to be explaining about the abstract part. So this experiment is carried out to actually determine two things, which are the heat capacity of various metals as well as the entropy generated when these metals are thrown into a container filled with water. Heat capacity estimation and entropy generation analysis of heat transfer are carried out in this experiment, in which the hot metal is actually added to the beaker containing a known volume of room temperature water and is covered with aluminium foil to ensure the accuracy of the data collected on the temperature change of the water in the beaker. The temperature of the water in the beaker was raised somewhat as the heat from the metal travels into the water, resulting in a temperature change. The temperature change in water is then monitored in order to calculate the specific heat of the metals, which allows us to calculate the heat absorbed by the water and also the heat emitted by the metal. It actually makes it simple to determine the heat capacity of unknown metal. So the total entropy created for aluminium and iron was actually greater than copper after the experiment. Due to the several circumstances and errors during the experiment, the experimental results actually differs from the theoretical values. So next slide. So there are actually two objectives that we need to succeed in the experiment, which are to estimate the heat capacity of different metals provided, and also to estimate the entropy generated when these metals are dropped in a container containing water. So next slide. So this is part 4, introduction. So the main goal, as I said from before, is to calculate heat capacity of various metals and the entropy generated when these metals are placed into a water container. This will be accomplished by combining two different substances and actually measuring their initial temperature, then measuring their ultimate temperatures when they reach thermal equilibrium, and calculating the entropy generated in the process.
Okay, my name is Muhammad Arsi bin Abdul, N19E-T0136. I will continue with the theory part. Heat capacity is the amount of heat required to raise a body temperature by 1 degree Celsius. When two bodies of different temperature exchange heat, the quantity of heat lost by the warmer body equal to the amount acquired by the cooler body, resulting in intermediate equilibrium temperature. As long no heat is lost to the environment, this is true. In this experiment, a heated solid with known mass M and temperature is placed in a calorimeter containing known mass M2 of cool water. The equilibrium temperature is only calculated after that. The quantity of heat lost by the solid and the amount of heat received by the water must be equal, which is heat lost by the solid equal to mCp T2 solid minus T1 solid. Heat gained by water equal to M2 Cp T2 water minus T1 water, which is Cp water equal to 4.187 kJ per kilogram Kelvin. At equilibrium, T2 solid is equal to T2 water. The entropy shift of a system or its environment might be negative. However, the overall entropy production remains positive. The growth of entropy principle dictates that the process moves in a certain direction, as gain is more than zero. The magnitude of irreversibilities present during the process are measured by the entropy generation. The entropy generated during this procedure is calculated using the following formula, which is delta S equal to mCp ln T2 over T1. Delta S total equal to delta S metal plus delta S water.
Hello everyone, I am Muhammad Al-Hafiz. I will continue the presentation about the apparatus and results part. So, the apparatus used in this experiment are metal spring, thermometer, aluminium foil, iron metal, aluminium metal, copper metal, beakers, water, hot plate, and weighing scale.
Okay, for the methodology and procedure, for the first step is the metal weight by weight scale and the value recorded. For the second, 100 milliliter of water filled into the beaker, and the beaker was heated using a hot plate. For the third procedure, the metal string attached the copper block and loaded it inside the heated water until it fully submerged. For number 4 is the copper allowed inside the water until the temperature becomes 80 degrees Celsius. And then 100 milliliter of water filled into the second beaker and the initial temperature measured. Measured the temperature of water in the first beaker. Okay, for the seventh step, the copper was taken out using a metal string, and the copper transferred immediately to the second beaker once the heated water reached 80 degrees Celsius. And then the beaker was covered by aluminum foil to minimize heat losses to the surrounding. The temperature of water was recorded for every minute until reaching the constant temperature. After all that, stir and the water throughout the process to ensure heat distribution. Okay, for the last step, the step repeated by using aluminum and the iron block.
So this is the result and calculation for this experiment. This is the data given by the lecturer. So we need to calculate the specific heat capacity of metal at 25 degrees Celsius, entropy change of metal, entropy change of water, and total entropy generated. So we need to calculate the specific heat capacity. We need to use the formula heat loss by solid is equals to heat gain by water, which is the formula used is m solid times specific heat capacity times delta T equals to mass of water times specific heat capacity of water times delta T, the temperature, the difference in temperature. So this is the result. For the specific heat capacity of copper is 0.5296, for aluminum 1.3563, for iron and is 0.6450. So for the entropy change, the formula is mass times specific heat capacity times ln T2 over T1. For copper, we gain the value is negative 0.089, for aluminum negative 0.007, and for iron we got the value is negative 0.0102. So we need to calculate the entropy change of water. The formula is same. So for water plus copper, we got 0.041. For aluminum plus water, 0.0028, and iron plus water is 0.0055. We need to total up the entropy. So we just use the formula entropy total is equals to entropy metal plus entropy of water. So for the copper, the value is negative 0.00848. We just add the entropy change of metal plus entropy change of water. For aluminum, the value is negative 0.0049, and for iron is negative 0.0047. So after that, we need to calculate the percentage error of the heat capacity. The formula is specific heat capacity experimental minus the specific heat capacity of actual value over specific heat capacity of actual value times 100. So for the copper, the percentage error is 37.56%. For aluminum, the error is 50.7%, and for the iron, the percentage of error is 45.27.
Okay, my name is Muhammad Afan bin Syafidi. So I will present for discussion and conclusion. So for the discussion part, first is the question asked about source of error and method to minimize the error. So according to the experiment that has been done, there are differences in value of CP theoretical and CP experimental for the three metal, which are aluminium, copper, and iron. So the value of heat capacity or CP experimental for three type of metal is higher than the value of CP theoretical. This will affect the value of error for three metal. Basically, this error occur due to some factor. As I state below, first is due to heat loss to surrounding due to convection. Second is energy generated to the water by stirring, because in this experiment we use stirring method in order to help to prevent non-uniform heating. And third factor is about parallax error. When reading the data during conduct the experiment. What about heat loss due to conduction? Because in this experiment, the metal was dropped into the container that containing water, and the data was recorded. So the connection between or the contact between the metal and the container will lead to the conduction of heat transfer. And the final factor or the last factor may be due to electric balance was used in this experiment, but it is without windshield. So the reading of the mass of metal is not accurate due to wind. So to overcome with the factor that affected to the error in this experiment is first heat loss. To minimize heat loss in the experiment, we can conduct the experiment by using closed system instead of using open system. Second, energy generated to the water can be lessened by stirring slowly, as the rate of stirring needs to be high enough to generate the energy. Third is maybe can reduce parallax error by taking the reading in which the eyes must be perpendicular to the measurement scale. Fourth is hanging the metal with stirring and immersing the metal into the cold water without any contact with container to reduce heat loss conduction. And lastly is maybe we can use electric balance with windshield, or maybe we can take the reading 3 times and then get the average reading. Second question in this discussion about the importance of stirring the water in the container. So the water in the container need to be stirred, because stirring will give more accurate data. The heat transfer is limited by natural convection without stirring. So the stirring method will ensure the temperature in the container will keep constant when the reading is taken. Third one is about the importance of transfer the heat metal quickly into the water. So actually the hot metal must be transferred quickly into the water, because metal are very good conductor of heat conductor. So after removing of metal from the hot water bath, if there is a retention of time, the metal will no longer be at the temperature of the hot water. Therefore, the water in the container will be heated to a lower temperature, and that is the reason why it is very important to quickly transfer the hot metal quickly into the water. And for the conclusion is experiment is carried out by using 3 different metal as mentioned just now, which are iron, aluminium, and copper, to estimate the heat capacity and the entropy generated when this metal were dropped into a container. which contain with water. So from the result obtained, the percentage of error is very small. This is because we conduct the experiment in a proper way, but it is still got the differences due to some error during conducting the experiment. At the end of the experiment, the estimated value of heat capacity had been obtained, at which aluminium have the highest value of heat capacity, which is about 1.3563 kilojoule per kg Kelvin, followed by iron and copper, which are 0.6450 kilojoule per kg Kelvin and 0.5296 kilojoule per kg Kelvin respectively. While for the total entropy generation of iron when it is dropped into a container that contains water is negative 0.0047 kilojoule per Kelvin, where it is the highest among copper, which only obtained 0.0048 kilojoule per Kelvin, and followed by aluminium, where the entropy generation is about 0.0049 kilojoule per kg kilojoule per Kelvin entropy generation. So at the end of the experiment, what we can conclude is that the experiment was done successfully and the objective of the experiment was achieved. So I think that's all from our group. Thank you.